given. We actually have two more givens in this problem that are not currently written down, but are in the diagram. So what else is given based on the diagram? Tori? Right. These two things right here. Those are given for you. So let's write them down. ST equals 7x. TU equals, is it 3x plus 20? Yeah. So stuff that's written in the picture is also given for you. All right. If you look at the next line in the proof, the next statement that is given to you, is already done for you, is that ST is congruent to, segment ST is congruent to segment TU. This is what I'm telling you. It's okay with me if you skip this step. So instead of saying congruent, you could go right here to saying ST is equal to SU because of the definition of a midpoint, because it cuts it in half. I don't need you to use congruent right now in the definition of congruent segments. We'll get there, and we'll start using that more. But I'm not going to make you do that for right now. So you can just say they're equal because of that. Yeah, Tori?
How would you be able to say that?
We're going to mark that they're congruent in the diagram, so now we're going to get to marking it. But we have to be the ones to mark it, because all we were told was there's a midpoint, but we know, because it's a midpoint, we can conclude congruent. Equal in measure. We could say they're equal because they're congruent. Okay, then it goes to this step, 7x is equal to 3x plus 20. How do we get there? Sam, what happened?
We substituted.
Right, so we were told ST is equal to 7x, and TU is equal to 3x plus 20. So instead of putting those letters, now we're going to put what they're actually equal to and replace it. So this is, in fact, the substitution property of equality. Next thing it says is that we subtract. If we think about it, what could you possibly be subtracting in this? Yeah, so if I subtract 3x from 7x, what do I have for my next equation?
4x plus 20.
Yep, 4x equals 20. Because we're subtracting 3x on both sides. So that's the subtraction property of equality. And then we get to what we're proving. X equals 5. How, Luke?
Division.
Right, so if we divide by 4 on both sides. Division, property of equality. Sweet. Think about your steps again that we talked about yesterday. Look over here by the whiteboard. First thing we do is mark your givens on the diagram. Our givens are that BD is an angled bisector. Okay, if we know that BD is an angled bisector, what do we know is going to happen? The two angles are going to be congruent, so we can go ahead and mark that now. We're going to still have to say that, but we can go ahead and mark it to remind ourselves, hey, I need to say that these two things are congruent. And then it also says that measure of angle 1 is 40 degrees. Mark that in your diagram. So go to measure of angle 1 and write that it's 40 degrees. The other part where it says prove, you do not mark because you do not know it yet. That is what you're trying to get to. So that's the very last thing we say. We put it at the very end. Measure of angle measure of angle ABC is equal to 80 degrees. That's the last thing we're going to say because it's what we are trying to prove. You cannot assume that it's true until you show step by step that it is. So step 1, mark what you know based upon your given. Step 2, ask yourself, it's right over here, does what you're trying to prove make sense? And if so, why? So it's super helpful to think through it and think, okay, it does make sense, and here's the reasons why. That way you kind of have an outline in your head for how you're going to get there. So Brennan said they're going to be equal to each other because you got an angle bisector. So that means the other one's going to be 42, and then you're going to add them up. That's exactly what we're going to do. So let's start by writing our givens. You have to copy them down exactly as you see them. So BD is an angle bisector. You cannot say the two angles are congruent yet. I know we marked it, but it is not given to us. And you are also given measure of angle 1 is equal to 40 degrees. So that's the information you get to use moving forward.
ABB is equal to DBC.
Yeah. So let's use 1 and 2 instead because it's easier to write. So we're going to say measure of angle 1 is equal to the measure of angle 2 because the definition says that it cuts it into two congruent parts, so they're equal in measure. The next reason I gave you was that we're going to substitute. What could we substitute here? Look at what you're given. Look at what you have here. Sophia, what could I substitute?
You can put 40 for measure of angle 1.
Right, so we know that angle 1 is 40. Circle. Measure of angle 1 is 40. So instead of putting measure of angle 1, we get to put 40. So we're going to literally write 40 equals 40 degrees equals measure of angle 2. You replaced 1 with 40 degrees. And look now. Now we just proved that measure of angle 2 is equal to 40 degrees. Okay, we're going to use those measures here in a second. But before we do that, we got to add up the angles. Because if we want to get ABC, then we have to use the angle addition postulate. So could someone please tell me what is my equation going to be when I use the angle addition postulate here?
Measure of angle ABC plus measure of angle DBC equals measure of angle ABC.
Yeah. I'm going to do the exact same thing, except I'm going to use angles 1 and 2, because they're also marked that way. Measure of angle 1 plus measure of angle 2 equals the measure of angle ABC. Part plus part equals whole. What could I substitute? Can you please tell your partner what can you substitute into that equation? Because that's what we're doing next, is substitution. Megan, what can I substitute? So let's, instead of putting measure of angle 1 and 2, let's put 40 plus 40 equals measure of angle ABC. And if you're confused on how I got that, I'll highlight it for you so you can see. So measure of angle 1 is 40. Measure of angle 2 is 40. So we're putting it in these two spots. Okay. So if I combine like terms, Liz, what would I write if I'm combining like terms? And your order does matter, and so the last thing that is written for you is that measure of angle ABC is equal to 80 degrees. So you got to swap the order using symmetric. Write your givens and mark them in your diagram. So I'm going to put the right angle to mark that. I put that little box in the corner, like you see in blue on my screen. Do not write angle TVK is 90 degrees. That is not what it says. It says angle TVK is a right angle. We'll get to 90 degrees, but you can't jump there right away. That is not what you were told. You were told it was a right angle, so you have to write that down exactly like it says and say that it's given. Okay, we know that it's a right angle. Using the definition of the right angle, what do I say next? Yeah. Measure angle TVK equals 90 degrees. Good. We are proving that angle 1 is complementary So angle 2, that goes at the very end. Think about, does that make sense and why? Can you please discuss that with your partner? What we're going to do next is go ahead and add them together. So if I'm adding together my angles, it'll say, you cannot say measure of angle 1 plus measure of angle 2 equals 90 degrees. You have to start by just using the letters. Measure of angle 1 plus measure of angle 2 is equal to the measure of angle TVK. Use their names first, and then you can put in the numbers. Put in the degree measures, or the lengths. Yeah?
Here we need to substitute TVK for 90 degrees.
Nice, yep. Put that 90 degrees where you see TVK. So instead, we're going to write measure of angle 1 plus measure of angle 2 equals 90 degrees. And Aubrey said that's because we did substitution. Because we said they add to 90 degrees, we can say they are complementary because of the definition of complementary angles, which say they add to 90 degrees.